This is module A3, objective 4. We're going to look at the differences between compact and spongy bone. In lab, we viewed the histology of compact bone, and we noted then that the basic unit of compact bone is the osteon. Remember that within an osteon we have many concentric lamella that are situated around a blood supply. And if you remember, the blood supply is runs through the central canal. This carries not only blood vessels but nerves through the bone. And along with those central canals, we also find a number of perforating canals. And these are canals that tend to run perpendicular to the central canals. And these perforating canals help deliver a blood supply to deeper osteons within the compact bone. But it also brings a blood supply to the tissues of the medullary cavity. The other type of lamellae that we'll discuss will be the circumferential, and up here we have the circumferential lamellae. And these circumferential lamellae surround the organ itself, and they're going to be in close association with the periosteum. And remember, the periosteum is this membrane covering that we'll discuss in more detail shortly. Spongy bone does not contain osteons. In fact, the matrix is nothing more than a network of what are known as trabeculae. Trabeculae in Latin, here's the word here. Trabeculae in Latin means small beam. And if you look at trabeculae, all you have are all these little beams that are connecting to one another, creating this scaffolding, if you will. There's no major vasculature associated with the trabeculae, and we find that these trabeculae create a lot of open space. You can see a tremendous amount of space left in between these struts, and of course in life this space is filled with bone marrow. And we discussed bone marrow as coming in different forms. Back up here, we have red bone marrow associated with blood cell production. And then we have yellow bone marrow. And of course, this is largely due to the infusion of adipocytes. So yellow marrow has a high fat content. So why do we have this this relationship? Why not have solid compact bone throughout the entire structure? You can imagine that a solid bone would be a lot stronger than one that has this hollow central region. And the answer is simple. It would be too heavy to have a solid compact bone. So the medullary cavity and the spongy bone reduces the weight tremendously. But that really doesn't answer the question in terms of strength. Yes, a combination of compact bone and spongy bone does appear to be weaker, but if we look at how weight or how mass is distributed throughout the bone, it kind of gives us an idea of how this works. Over here, this is figure 6-7 from the text, and this is basically a section of a femur. Here we have the head of the femur. The head of the femur is going to articulate with the hip joint, the hip socket. And basically, if we look at the axis of body weight, it runs about here, with the other head of the femur situated on the other side. So as body weight is applied, as this force is applied, It then is transferred into the femur where it runs down the medial side of the femur all the way to the knee. And then the knee is going to support the bulk of that weight. And as this weight is applied to the medial side, we have compression. The bone in that region is undergoing compression. And if we look at the arrows themselves, we see that the arrows are one-ended as they run down to the knee. They're then going to be, that force is going to be transferred to the knee itself. On the other side of the femur, on the lateral side, to help compensate that compression, we have tension. And tension is going to pull the bone in opposite directions. So it's through a combination of compression on the medial side of the shaft and tension on the lateral side that this system can accommodate the actual body weight itself. In Objective 5, we're going to look at the periosteum and endosteum in more detail. And we'll start with the periosteum. Of course, again, the periosteum is a membrane that covers the outside of the bone. And you're going to find it on all bones except those parts or those regions that are enclosed in a joint capsule. The periosteum itself is made of two layers. There's a fibrous layer on the outside and an intercellular layer. And what types of cells would you expect to find in the periosteum? Start thinking about that now, and we'll come back to that in a minute. Another property of the periosteum is the perforating fibers. And these are collagen fibers that originate within the periosteum, and they embed themselves within the osteons, or the lamellae, of the compact bone. And in areas where you have the attachment of tendons or the attachment of ligaments, in the case of muscles, we find that, again, we have more collagenous fibers that are kind of weaving themselves into the compact bone. And let's just kind of take a look at that. Right here we have the perforating fibers. It doesn't show it tremendously well, but if we were to look at this, we find that these collagen fibers from the periosteum are literally embedding themselves into the circumferential lamellae of the compact bone. And that's going to create a tremendous strength, basically. In fact, if you were to pull on a tendon or a ligament, it's more likely that the bone will snap before that tendon or ligament is torn out of the bone itself. So it creates a very powerful, very tough, strong connection. Functions of the periosteum. The periosteum isolates bones from all surrounding tissues. It's going to create an entry point or route for both the circulatory and nervous systems. And the periosteum participates in bone growth and repair. And again, this is mainly due to the cell types that are found within the periosteum. On compact bone, the inner region, or the inside of the compact bone, is covered with endosteum. And again, this is a very thin epithelial-like layer. It's referred to as incomplete, and we'll look at why it's incomplete in a minute. And the endosteum lines medullary cavities, and it's also going to coat or cover both the trabeculae of the spongy bone as well as the central canals. Within the endosteum, we're going to find 4 cell types. We have osteoblasts, which, remember, aids in matrix building, promotion. And osteoblasts also give rise to osteocytes once embedded within the matrix. We have the osteoprogenitor cells. These are mesenchymal stem cells that will eventually differentiate into osteoblasts. And then we also have the osteoclasts. And remember, these cells are associated with bone recycling. Osteoclasts release a tremendous amount of digestive enzymes which really break down the matrix, releasing those minerals back into circulation. And it's through the activities of these cells that enable the endosteum to help participate in both bone growth and repair. Here's a figure 6.8b. This is the endosteum. And again, we find that this is a very thin cellular layer. And the endosteum is considered incomplete because it's not complete. Right here in the middle, we have a large osteoclast. We would know that that's an osteoclast due to the multinucleate appearance. There's multiple nuclei. As well as the osteoprogenitor cell. So it's incomplete. The endosteum does not line the inside of the medullary cavity in its entirety. It's often interrupted by other cell types.